The main cause of various electric vehicle fires that you have heard or seen is thermal runaway of the battery, which can be roughly divided into three types. First, the high temperature of the environment causes a violent reaction between the positive and negative electrodes of the battery, which releases a large amount of energy into the combustible electrolyte and releases oxygen, causing the battery to expand, overheat, and even catch fire. Second, external damage caused the battery splitter to be penetrated. Indirect contact between the positive and negative poles leads to a short circuit inside the battery, releasing a large amount of electrical energy in a short period of time, leading to a thermal runaway of the battery. The internal structure damage caused by overcharging or discharging of the battery can lead to thermal runaway of the battery. So, what is the thermal runaway of the battery? Thermal runaway refers to a situation where lithium-ion liquid battery experiences external high temperatures, internal short circuits, water ingress into the battery pack, or various external and internal factors such as a high current charging and discharging, causing the positive and negative electrodes inside the battery to heat themselves, or directly short circuits, triggering thermal triggering. In a short period of time, the heat cannot diffuse and temperature gradually increases. The SER film and electrolyte of the surface of the negative electrodes in the battery positive and negative electrodes undergo a series of thermal runaway reactions at high temperatures. Taking lithium-ion batteries as an example, when the temperature reaches 90 degrees, the SER film on the negative electrode surface begins to decompose, and after the temperature rises again, the diaphragm between the positive and negative electrodes shrinks and decomposes when exposed to high temperature, causing direct contact between the positive and negative electrodes. The short circuit causes a large amount of the heat and sparks, leading to a further increase in temperature. When the heat loses control, a high temperature of over 200 degrees Celsius causes the electrolyte to mostly completely evaporate and decompose. It contains a large amount of flammable and explosive organic solvents, which will gradually be affected by thermal runaway and eventually decompose into combustion, which is an important reason for thermal runaway. Can thermal runaway be avoided? It's not realistic to completely eliminate the thermal runaway from the individual level in lithium batteries at present, but we can prevent induction and spread through the control design of the battery management system, BMS. Even if the individual experiences thermal runaway, accidents will not occur easily. In terms of BMS, it is possible to choose to install thermal runaway logic. The BMS with thermal runaway logic will monitor the voltage and temperature rise changes of the battery cell in real time. If the individual voltage continues to decrease, such as 0.2 volts or more, decrease per second for 3 seconds, and the instantaneous temperature rise of battery is too large, exceeding 10 degrees every 2 seconds, etc., a thermal runaway alarm will be triggered, and the charging and discharging mode tubes will be instantly turned off, causing the battery to pop off, thereby preventing further danger from occurring. In the event of the inevitable battery thermal runaway, timely warning and sufficient escape time for passengers are essential. And in a sense, there's also a form of safety. Okay, this is the end. Hope you like it. See you next time. Bye.